Recording in progress.
All right. So perfect audio and video. Please check everyone. The text is looking fine. Please see. All right. So see first, before introducing aptitude, let me introduce myself. So my name is Ankit without H, okay? Single. So this is my name. You can call me as Ankit. Now, I will be handling for you guys aptitude as well as reasoning as of now. Okay. Here in CodeNest, I have been associated with the last 3 years since the COVID times. I am here. So 3 years I am having experience in CodeNest. Before that, I used to teach engineering subject like signal systems, circuit theory, and control systems. Okay, these were my subjects. Now, please remember this. We are starting with aptitude, though. So that first class excitement that should be there. It should be there in the last also. Or if in case I say enthusiasm is not for the class, it should be for the subject always. So if in case you have missed the class, you should not miss the subject other than the class. That is what I mean to say. Meaning, the problem actually with the coaching, whenever you take coaching, the problem is in this college, we never study, right? Hardly 1 hour self-study. If we count the college hours also, 1 hour of study. Okay. So, just a minute, please. Just a minute, guys. Any problem with the audio and video? Please check. Okay. Yeah. So the problem actually what the student faces, suddenly you come from a time in which your self-study was 1 hour, and now you are having classes for 6-7 hours. After that, you have to self-study also. So that becomes a problem, drastic change, right? So that drastic change, most of you cannot manage. Similarly, in our time also, if I say how much was my attendance in the college, I will say 10-15% maximum. That was my attendance. But when I did coaching, what was my attendance? I will say 100%. I never skipped any classes. There were 2 reasons. The first reason was I paid 70,000 for it. That was the first reason, not me, my dad. The second reason was the teachers who were there will not be on YouTube. That was the second reason. Okay. So because of those 2 reasons, I never skipped any classes and I enjoyed it also. Although it was from 7:30 to 2 o'clock. Again, it was a drastic change because I was not going to college. I was going to the coaching institute. So like back-to-back 6 hours classes, and that too of engineering subject, and that too the questions are gate level. Okay. So the problems you have faced, I have already faced. And only the time was different. The way of preparation was different. Maybe the difficulty level also was different. Okay. But yes, these problems we face because there we were having like 13, 14 subjects. And you guys are also having 7, 8 subjects, if I say. Okay. So please try to do something. Please try to manage all the subjects. At least I will say, not all the subject, at least 2 subject if you master. I'm saying master, not touch. 2 subject master it, and the remaining 3, 4 subjects, you please have a basic knowledge of that. But 2 subject you master. Okay. Now, coming to the aptitude. So basically a little bit definition so that you can get to know why we are actually studying it. So it's not like they have to just take a test to eliminate you. It's not like this. There is a reason behind why aptitude is very famous in the selection industry. Why only this test? Why not GK? Why not something else? Why not a subject from your engineering background? Okay, so there is a reason behind it. Now, just a minute, please. I will have to take pause in between. I'm not well today. Okay. All right. So first, read some definition. Then I will tell you why actually they are asking aptitude and reasoning. Okay. Now, so what is aptitude? It's basically ability to perform a particular task. You see, it's not math. It's a particular task. It can be anything. So, for example, like a bodybuilder, he has the ability to lift weights. For example, Lionel Messi, he has the ability to dribble and score goals. Okay. Now, Ronaldo also able to score goals. Then Sachin Tendulkar, Kohli, and so many players are there. They have the ability of good batting, right? Then good bowling and so many things are there. If I say particular task can be anything. So, what I'm trying here to say is ability to perform a particular task can be anything. You can be good at anything. So why they are asking about quantitative aptitude? That is the point. So think for yourself that you are a owner of a certain company. Okay. You yourself are a fool, but you want to hire educated person. How will you check other person's education? I mean, what you will check? Not how. What you will check? Answer please. What you will check? You are a fool, but you have person who can check other person's education level. So what you will check? At least I'm saying, at least what you will check. What you will check? Degree. Okay. Degree I can give you for 2000 rupees. What else? General knowledge. So general knowledge, I can check if it is a news company or something like that. Okay. Now imagine, for example, I don't know whether you have traveled in metro or not. So like metro stations, they usually talk to you using signs. Okay. There are not digital boards, so many things. Just arrows and so many things will be there to tell you, okay, this is platform 1, this is platform number 2, something like this, they will tell you. Okay. Then, so that the passenger get to know that next station is what, previous station is what, like how many stations are on that line. So that all things they will show using a map. Okay. Now think for yourself that you are experienced. You have traveled so many times in metro. Now suddenly one Desi person comes, and that Desi person comes for the first time in metro with you. And he is not able to see. It's properly written this way. This is platform number 2. And he is asking you, where is platform number 2? What you will think of him? It's clearly written this way, platform number 2. And he is asking from you, which way is platform 2? What you will think? Your thinking about him will be negative or not? That he is a fool. You will not care, okay, he has come from village, but you will think he is a fool, right? This is what the normal mindset is. So if you cannot understand basic science, basic sign language, if I say, properly written everywhere, airports also, that luggage belt will be there. So many things are there. Which luggage belt you have to go to? There is a screen on it. Flight number is written. So many things are written to tell you which is the luggage belt. Now, so many things are there which to tell you that which is your outdoor. I mean, from where you have to take exit, from where you have to take your bus for the flight. So many things are there. So if you go for the first time, that is how they have created all the signs. It is not like for a experienced person. And if you don't understand it, that means you have a little bit low level of understanding skills or logical skills. Okay, so these basic things, basically they are checking something which is a general intelligence, general, which should be with every person, whether it is a testing guy, whether it is a salesperson, whether it is a operations guy, whether it is a Java person, back end, front end, whatever it is. Some general skill set you should have. That general skill set they will check using quantitative aptitude and logical reasoning. General skill set. General means it should be universally present in all the human beings. Okay. Now, for example, let me tell you this. There was a time when this online purchasing was increasing. It was not like as of today, it was not that much, but there was a time like 2016-17 I'm talking. The online purchasing was increasing among the masses. Now, I used to do the online shopping because I never like to go like 40 kilometers to buy something. It was not my way. So that's why I was always into online purchasing. So my dad also watches me. Okay, he's purchasing something. So now, one day he also was curious that how this works. Okay, he was also curious. So he ordered one toothpaste. First, he checked the price in the market. Okay, first. So suppose, I do not actually remember. Suppose in the market it was 100 rupees. Here it was 80 rupees as the price I'm saying. So this was one toothpaste. So market price 100 rupees, there it was 80 rupees. So he was very happy that I'm saving 20 rupees. So he ordered it. Now when he ordered it, he didn't check, okay, what is in the checkout, how much price they are asking. No, he didn't see. He just checked on the page. Okay, toothpaste price showing as 80 rupees. Okay, done. Now he made the payment. In the payment, there was 150 rupees delivery. He didn't check how much money was debited. He didn't check anything. 150 rupees delivery charges, and he was very happy that I sent 20 rupees. And then he goes to my mother that he's saying, I save 20 rupees in one toothpaste, 20 rupees in one toothpaste. Like that, he is very happy. Now, I didn't say anything that day. After 2 days, when the delivery came, then I said, this delivery guy, 150 rupees you gave him. Okay. So that's how he get to know, okay, this is what I have done. So, this is something like the times are changing. I'm not saying my dad, if I say he's a very educated person, extremely. I'm not saying educated means he knows astrophysics. No, I'm saying he is educated. If I say when I was in school and I was reading something in English, and if I ask him, Dad, what is the meaning of accurately? He will answer me. Although there was a long back he studied English, long back my mother studied English, but there were so many words which I never searched in the dictionary. They used to tell me. Okay, so he's not a fool person. What I'm saying is times are changing. So our skill set, which I'm saying general skill set, that also is changing. Now, this is something which is, I'm saying it is a problem, right? This online shopping, it is a new thing. This artificial intelligence, it is a new thing. Maybe I'm having intelligence while doing the online purchasing. Okay, how to save money, how to get coupons and all that things. I have that intelligence. But when it comes to artificial intelligence, I'm feeling outdated. I'm not able to cope up with this new emerging times. So I'm thinking, okay, how should I use it? How should I use it? And then I'm kind of thinking, okay, let's keep settled in the old ways. No, don't change. Okay. Don't use ChatGPT, don't use any of these artificial intelligence tools. But the problem, what will happen is 10 years later, maybe right now I'm not feeling the necessity of using those tools. But if I don't use those tools, maybe I will have to retire because of not having a job. Not with the job, without the job, maybe I will have to retire. This is how the times are changing. Okay. So some general skill set always you should have. So one thing is quantitative. Quantity has the word quantity. So quantity means the skill set of understanding the numbers. So many numbers are you are observing in daily life. In your phone, you are observing numbers. Maybe your batch, that also has a number. Calendar. You see, every day is represented with a number, right? If I say, when you go to shopping, you should have the intelligence of numbers. Otherwise, you will make a loss, right? So you should have you should be comfortable with the numbers. You should have some basic understanding, some mathematical and numerical problems you should be able to solve. Some basic, not complex. Now, some reasoning skills. Reasoning means, for example, like I said, it's properly written, okay, this way it is a platform number 2, but you are not able to understand. So that means you have low reasoning skills. You don't have the logical abilities to understand some figures. So some logical reasoning, I mean to say, some logical skill set. Reasoning is something else. Reasoning means it's something like, for example, extremely important. If I say in managerial terms, reasoning is something like you are seeing the data of a very big company. All the data is present in front of you and you have to take some critical decisions. So when you are taking some critical decisions, so many parameters are there which should affect your decisions. Okay. Now, when you are saying something, when you are concluding something as a manager, because you are a person of influence, your any decision can affect the company growth. So when you are saying something, concluding something out of the data, you should have some reason behind it. It should be logical and there should be a reason behind it. Okay, so that's why the term name is logical reasoning. The ability to make logical conclusions. That is the meaning of logical reasoning. Now, let's not waste too much time now in this. See the syllabus first. This is what we will be learning in this course. So carefully look at the syllabus. Okay. So we have first some number-based chapters. After this, all of this is actually language-based problems. Everywhere you will see some language. It's not like X into Y into Z. No. X into Y into Z means I call it as number-based problem. Now, for example, if I say problems on ages, the present age of this and this is in the ratio 2:3. After this many years, the ratio will become this. So language, some language is there, and based on the language, different concepts, some problems are framed. Okay, so those different, I mean, other than all this, all the chapters, if you are observing, they are having the language-based question. Okay, so all the chapters I feel is familiar with you guys. If I see, is any chapter which you have never heard of? Please see that. Any chapter which you have never heard of? See, please. All right. So, please always remember this. You are not gaining knowledge. You want to crack something. Okay. And every time it should be your mindset, you have to crack something. Knowledge is something which should be for a professor. Okay. If you want to be a PhD in mathematics, then keep on learning maths. Whatever topic it is, just learn it. Now here, right now, you want to crack something. You want to crack aptitude exam. You don't want to learn aptitude, to be precise. You want to just crack aptitude exam and done with this subject. After that, it is Java. So many things are there. Whatever is your domain, you will get. So what I'm trying to say is, in life, the strategy is very important. How much time you should give to what topic or what subject? How much time? First, you will have to see the requirement. It's not like, for example, it's not always about knowledge. For example, if I say, probability, if I say, so probability is one area. If you see and search the probability book also, one thick books will be there. So I'm not saying probability you have to gain the knowledge that much that you can solve that book. Probability, it's not, I'm saying like some integration formulas are also there, some summation formulas also will be there in probability, which will be required for communication systems. But I'm not saying go to that level. That is not required. So suppose some IIT JEE question comes in front of you from probability, because this chapter also is in IIT JEE syllabus. So suddenly one question comes from probability. You see, okay, this is IIT JEE, this. Okay, now you are curious, okay, see if I am able to solve it. But IIT JEE is not your concern, so leave it. So that patience you should have. That question is not of my concern. It came in CAT, not of my concern. It came in CAT, somebody who is learning for CAT, he will solve it. I will not solve it. Because you are studying to crack the IT exam, not CAT level exam, not IIT JEE. So that you should just leave it. Okay. It's something like, for example, if somebody comes to you and say, oh, from tomorrow, let's join the dance classes. Will you join it? Answer, please. Will you join it? Let's join the dance classes and we will go to Mumbai and so many places and we will just perform in some show. Will you join it? No. Because why you will not join it? Because that is not the career you have chosen. So that probability question which came in IIT JEE is not your concern because you have not chosen IIT. IIT is long back. That is gone. So past is past, leave the past and don't check your knowledge for IIT JEE now. That time is gone. Yes, you can check for GATE because GATE exam you can give. But again, until you finalize, okay, I want to prepare for GATE, you will not take probability question of GATE. Till you are clear that I have to clear the IT industry exams, it should be very clear what probability question you will have to solve. Okay, and it should be something like this. Whenever you are searching question, you will search it like this. Probability previous year TCS question, Tech Mahindra question, Capgemini question, like this only you will search. Otherwise, I cannot make sure that probability video, whatever you are seeing, or the probability question, whatever you are seeing, is from which exam. And exam is very important, extremely important. Why I'm saying this, please remember this. There was one friend of me. He went to tell interview for UPSC, I'm saying. Interview for UPSC exam. But he was not able to crack the bank exam. He was not able to crack the SSC exams. Okay. So every domain I'm saying UPSC, SSC and banking. Every domain has a particular requirement. So for you guys also, there is a particular requirement in the industry. So for you guys, this subject is just a wall. You just have to cross it. Once you cross it, how much of this will be required? I cannot make sure of it. It all depends. Okay. But yes, if I say to be in general, this subject will not be required after the placement. But yes, before the placement, it is necessary. Okay. And how much of this is required, that also should be very clear. I'll just wait for a minute. Okay, now see the reasoning chapters as well. All right. So these are some very important topics of reasoning, and please there will be some student who value aptitude more than reasoning, but please remember, sometimes reasoning becomes very important in some drives. Sometimes you will see only reasoning questions and no aptitude question. Maybe sometimes you will see mostly reasoning question and 1 or 2 aptitude questions. And sometimes you will see mostly aptitude question and 2-3 reasoning question. Okay. So all sorts of things are there. But like, for example, MNCs, they give equal importance nearly to aptitude and reasoning. But the startups, if I say, they can give a little bit more importance to reasoning, a little bit more. Okay, I'm saying startups. So please remember, reasoning is very important. Reasoning we will take later. First, we'll be taking aptitude. Okay, first aptitude, then we will take reasoning. So please, in the starting only, start to practice the reasoning question before even if I take the chapters. I mean to say, before even I take coding, decoding, just practice 10 questions on this, practice 10 questions on this, just practice 10 question on this, practice 10 question. Like this, if you get an idea, okay, what is this chapter, you will be able to perform moderate in a lot of drives before even I start this subject. Okay. So see, please, don't worry about if you are not able to understand any chapter name, don't worry about it. Leave it. Once we go to that chapter, it will be clear. All right. So should we start? Any general doubt? Or should we start? All right. So the first thing we are going into is number system. So number system which we use in our daily life, I'm saying daily life, not computers. In our daily life, that is decimal number system. For example, if I say what language I am speaking, you will say, sir, English. In English, what is the base? 26. Why 26 is the base? Because I have 26 letters A to Z. Using different combination of letters, words will be created. And using those words, I am speaking sentences. Right? So, like that, there are 26 letters in a language. So just like that, there is a number system in which there are 10 numbers present, using which you can create numbers. Or I should say like this, you have 10 digits. It's something like this. For example, if I write A, B, A is a letter or a word. Answer please. Letter or a word? A. It's a letter. It's not a word. Word means more than one letter. B. Is it a letter or a word? It is a letter. Abhi. Is it a letter? Answer please. No. It is a word. It has 1, 2, 3, 4. It is a 4-letter word. So just like this, here we have 10 digit. Digit is something like letters. In English, you have 26 letters. In number system, you have 10 digits. So 10 digits which you have is 0, 1, 2. 0 to 9. All these are called as digits. It's something like ABCD for numbers. Okay, so these are your digits. You will not call them as numbers. Okay, you call them as digits. Now, using these, you create whatever number you want. For example, using ABCD, suppose if I say this ABXPQ, create any word, whether it makes sense or not, create any word. Take any letter, any place, different orders, so many words you can create with meaning or without meaning. So here also, out of these 10 digits, take any 2 or 3 or 4, whatever you want, and create numbers. So, see please now. I have 9 digits, 10 digits, up to 9 I have. So the counting usually starts from 1. Okay. Now, so think like this. Long back, there were only 9 things to be counted, not more than 9. Anything was less than 9, not more. Okay. So the counting, it does not start with 0, but I'm starting from 0. So 0, 1, you're counting. Okay. There are objects to count. So long back, some person is counting. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. But after 9, there is nothing. I don't have a number for the, after 9, I don't have a number. Long back, I'm saying. Right now we have. But long back, we were having only 0 to 9. So now a new requirement came. I want to count more, but I don't have a number. What should I do? So that's how the 2-digit number concept came. Okay, 9. You have taken all the 10 digits you have used. Now you want to count more. So, okay, start with 2-digit numbers. Okay. 2-digit. So, when you are starting with 2-digit, the logic was you will not keep zero value at this place. So fix 1 first. Fix 1. 1 is fixed. 1 is fixed. And count like this. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, now. So you have fixed 1 and the same digits now you are using again. 1 with 0, 1 with 1, 1 with 2, 1 with 3, 1 with 4, like this. Now, suppose you came at 99. After 99, you don't have any 2-digit number. If you want to count more than 99, you don't have it. So next what? Answer please. All the 2-digit numbers taken. Now after 99, we don't have 2-digit numbers now. So that means I should have something now. So that's something. Okay, 2-digit numbers all are done. So now 3-digit number. So that's how 3-digit numbers came. All the 2-digit numbers used. Now there is a requirement of a 3-digit number. So it will start like this. Now fix 1 at this place. Okay. And start with 0 and 1, 0, 1, 0, like this you will start. And write 1, 2, 3, 4 like this. Okay. So this is how the counting has been designed. Why I'm telling you this is because I want to tell you that everything has a logic behind it. Everything. For example, if I say octal system, maybe you have got a little bit idea how the counting is designed in decimal system. That means our system. Now, octal system has 0 to 7. I'm saying, suppose, okay, after 75, tell me the next 5 numbers in octal system. What is the next 5 numbers I'm saying? Answer, please. Next 5 system numbers in octal system. Next 5 numbers. After 75, how 64 can come? Next 5 numbers. Okay, Fahim is correct. Please remember, these are the digits which you have in octal system. Sai Priyanka, correct. I'm saying numbers. I did not say 2-digit or 3-digit. So, as per the logic, 75, okay. So 7 fixed. Now, up to 7, you have to go 5, 6, and 7. Okay. Now, suppose if I write 78, I will say 8 is not available. 8 is not a digit here. So if 8 is not present, 78 cannot be available as a number in the system. You know 78, but octal system does not know 78 because 8 it does not understand. It's something like the computer does not understand 2. What is 2? It does not understand. It understands 0 and 1. So something in octal system does not understand 8. So 78 has no meaning. So that means all the 2-digit numbers are done. So now 3 digits will start. So when 3 digits start, it start like 1 is fixed at this place 0, and now start with 0, 1, 2, 3, 4, 5, 6, and 7. So 100, 101, 102, 107. Again 108 I have not written. 8 is not present. So this is how things are going in octal system. Okay. So in every system, what we have is 2-digit number, 3-digit number, 4-digit numbers, right? But for example, what knowledge will be required is, for example, if I say for decimal system, tell me the highest five-digit number all right. So these two numbers, please tell me. 5-digit, it means it should have 5 digits. 1, 2, 3, 4, 5. I mean 5 places it should have. At each of the place, you can use decimal system. That means at each of the place, you can think 0 to 9. Except this. 0 you cannot think. Now think of highest. So here there is no foundation. I'm just saying highest. So highest number, if I want to create, take the highest digit, which is 9, everywhere. Okay, so very easy. Highest number, take the highest digit at every place. Now here I'm saying all digits must be different. Why I'm saying this? Because this knowledge can be useful in permutation combinations. So here also again 5-digit. I want to create highest number 5-digit. All digits must be different. Okay. So take the highest now. At the first place, take the highest. Now I cannot repeat. So now take the next highest, which is 8. Take the next highest, take the next highest, take the next highest. So this is how you can create a numbers with a certain requirement. For example, if I say smallest, okay, so tell me now smallest. When I am saying number, a number should never start with 0. Okay, please remember that. So what is the smallest 5-digit number? It should not start with 0, but it can end with 0. All right. So some students are seeing 1, 1, 1, 1, 1. If previously it was 9, 9, 9, 9, 9, here you are thinking, okay, 1, 1, 1, 1, 1. Things are not always go the exact way. If previously it was 9, 9, 9, 9, 9, it's not like the same way you will say 1, 1, 1, 1, 1. Maybe you have just maybe you have recently seen the Golmaal movie. That's why you are saying the Vasuli by his number, right? So please don't say that. Think logically, please. The smallest number you want to create, it should not be 0. So next one is 1. Why not 9? Because I want to create smallest. Why not 0? Because 0 number should not start with 0. All right. Now, at the remaining places, think. Just a minute, please. All right. So sorry for the interruption. So smallest number you want to create. This is the smallest I can take because 0 is not allowed. Now at all these places, there is no boundation. So write 0. So this is the smallest number you can create. And that is a 5-digit number. Okay. Now come to this. I want to create smallest. Now the most valuable place in a 5-digit number is this. So this place has to be smallest. Why not 0? Because 0 is not allowed. First place 0 is never allowed. Now, all digits must be different. So next one should be different. So it should be different from 1. It should be smallest. So the next one is 2, next one is 3, next one is 4, next one is 5. So like this, we can think of numbers. And this way of thinking will be required in permutation combinations. Not always, but sometimes it will be beneficial. Okay, so clear with this? Yeah, right. All right. So are we correct here? 1 0 0 0 0. Are we correct here? Yes. But here some student will say, sir, 1, 2, 3. You are taking 1, 2, 3, 4, 5. Now suppose, sir, if I take 1, 0, 2, 3, 4. So that is also correct. And this will be least also. Some student can think like this also. He is thinking not like this. He is thinking, sir, you are taking this. So 1, 2, and if I say, sir, this number contains all the different digits. And sir, it is lesser than this. So what you have created? Okay. So 1, 0, 2, 3, 4. Please carefully see. Nine, 8, 7, 6, 5. Like this, 9, 9, 9, 9, 9. You said 1, 1, 1, 1, 1. That was wrong. Now 9, 8, 7, 6, 5. The same logic if I apply. Is it right? I want to create smallest. So 1, 2, 3, 4, 5. Like 9, 8, 7, 6, 5. If I apply the same way, I'm getting this. So is this right? Obviously not. So please remember this. Sometimes what I want to say is, I don't have that question. Sometimes what I'm saying is, a student think the same thing in a similar question. For example, I will tell you this. Once I take this question, let me make you see. Okay, that question is not there. Okay, so highest 5-digit number, all digits different, and smallest 5-digit number, all digits must be different, are two different things, not similar also. So if you apply something similar concept, 9, 8, 7, 6, 5, you are forgetting 0 here, right? So when you will be seeing that permutation combination videos, I will be insisting on 0, because 0 creates a problem because of two reasons. That 0 is not allowed, first place, that is the first thing. Now, when you are creating a certain number, you sometimes forget about 0. Okay, 0 is not allowed here. After 1, you are thinking 2. This is the very common mistake, because you are not thinking 0, because you are saying, okay, after 1, next smallest is 2. You are not thinking about the previous one. Okay, so things are there which kind of creates these confusions. So please remember this. 1, 2, 3, 4, 5. Most of you have mentioned, but there are some students who said, yes, sir, correct. You assumed it. I said something, you assumed it. So please, the same question sometimes I will do with two different approaches. So once I start taking questions, you will understand. Two same question, just change of values, I will change the approach. Okay, so things are not always having the same logic, even if the question looks similar. Okay, it all depends on the values which are given. It all depends on that. So start with some basic definitions. All right. So natural numbers are called as counting numbers. So counting starts from 1. So that means all the numbers starting from 1 and so on, ending is not there. So starting from 1 till the end, all the numbers are natural numbers. If you include 0 also, that means you are saying whole numbers. If you take their negative also, that means you are talking integers. So in integers, all natural number, their negative also and 0 also is included. Now, these are definitions. It's not like I want you guys to memorize it. No, it's something like sometimes they will say how many natural numbers this and this. Sometimes they will say how many whole numbers, what is the sum of these many whole numbers. Sometimes they will say how many integers are like this, are like this. So at least you should know, okay, this is a question of integers. So I can take -1 also. Okay, it is a question of natural numbers, so I can take 1. I cannot take -1. So these all things you should know. It is a whole number question, okay, so I can take 0. 0 is allowed because 0 is a whole number. Okay, so that's why only for these reasons I have included the definitions. Now, these definitions are very basic. Maybe you do not remember what is a composite number. So please read the definition of these two. So prime number is any natural number which has exactly 2 factors. Exactly 2. So one factor is 1 and one factor is the number itself. Now composite number, any number which is not prime is a composite. Okay. Now, again, these definitions are not very strict. For example, you can say, sir, 1, is it a composite number? So I will not say that. 1 is not a prime number. If it is not prime, is it composite? No. So these definitions are not very strict. Okay, so leave it as it is. Just think like this. For example, if I start writing the prime numbers, I will start with 2. Sometimes student asks, sir, why 1 is not a prime number? Because my dear, 1 has only one factor. The definition says exactly 2. It does not have 2 factors, so it is not a prime number. Okay. Now, 2, it has 2 factors, 1 and 2. 3, it has 2 factors, 1 and 3. Now 5 has 2 factors, 1 and 5. 7 has 2 factors, exactly 2, 1 and 7. Now don't say 8, don't say 9, don't say 10, say 11. It has 2 factors, 1 and 11. 13, 17, 19. So all these are prime numbers because they have exactly 2 factors. One factor is 1 always, always. So please remember this, 1 is a universal factor. Meaning what? 1 is a factor of any natural number. So that's why I'm saying 1 is a universal factor. Universal means for all. Any number you take, whether it is prime, whether it is composite or any number, 1 will be a factor always. Now, any number is divisible by itself. So n is always a factor of n. What is n? Any number. So any number that is a factor of itself. 10 is a factor of 10. 5 is a factor of 5. 6 is a factor of 6. So like this, any number is divisible by 1. Any number is divisible by itself also. So now, think composite number. I always say like this. For example, if I am saying, let's take 87. Now, if I say this number, obviously, this is very obvious, clear. 1 is a factor. 1 is a universal factor, so 1 is a factor of this also. Now it is very clear. 87 is divisible by 87. N is a factor of n. So don't tell me these two factors. Other than these two, tell me any other factor other than these two. So what are the factors? If there is any other factor, I will say it is a composite. If there is no other factor, I will say it is a prime. So what are the factors? 329. Correct. All right. Any other factor? I mean, we are not thinking about number of factors, but still. Now 3 and 29. Any other factor? No. So, because I have 1 is always a factor. 87 is a obvious factor. So other than these two, which is very obvious, other than these two, I have factors. So that means it is composite. If you are not able to think any factor, you will say prime. If you are able to think even one factor, you will say prime number. Composite number. If you are able to think factors, then say composite. If not, say prime. For example, if I say, for example, 91, don't tell me 1, don't tell me 91. These are very obvious. Everyone knows. Any number is divisible by 1, divisible by itself. Tell me something else. Other than these two, do we have any factor of 91? See, please. Other than these two, any other factor? No. So these are some numbers which, when you see for the first time, you will say this is a prime number. When you see for the first time, just like love at first sight, it is prime number at first sight. That is how these numbers are. 87, 91, these numbers. So there is a factor of this which is 13. There is a factor of this 7. And because there are factors, it is not prime. And not prime means it is composite. Okay. So it is also a composite number. It is not prime. It looks like prime. It feels prime, but it is not. Okay. So because it feels prime, there are other numbers also because they feel prime. That's why the companies sometimes create questions like this. So a very basic question, only small numbers they have taken. Small numbers. So only 2-digit numbers they have taken. So now think please, what is the right answer? 91. Just now we have seen it looks like a prime number, but it is not, because it has factors. It has factor of 13. It has a factor of 7 also. Okay. Now just answer please. Do you know what is a factor? And do you know it accurately? I'm not saying do you have an idea. I'm saying do you know 100% about what is a factor? Do you know this or not? 31 is a prime number. 61 also, 71 also, 91 is not prime. So, do you know what is a factor? I'm saying 100% knowledge. Do you have it? Okay. So, because I'm using these words, so that's why let me tell you first about the factor. For example, The factor word will be used whenever we are thinking something related to division. So, suppose I am dividing 91 with 7. I am dividing 91 with 13. I am dividing 91 with 14. Now, please perform the division. This will give you 13. This will give you 7. This will give you something decimal number. I am not calculating. This will give you 1 and this will give you 91. So, first thing, please remember this. Factor is a word in a division. Factor is a word used for denominator. Used for denominator. The factor word is never used for the number present in the numerator. Will you say 91 is a factor of 7? Will you say this? 91 is a factor of 7. Does it make sense? Because I have seen student making statement like this, sir, 91 is a factor of 7. They are confused. What is multiple? What is factor? So answer please. Will you say 91 is a factor of 7? Will you say this? Will you say no? Why? First thing, please. In a division, whenever you are performing division and you get, after performing division, you get integer. So integer means this. In this, you can use the word factor. You can think factor. Integer. So in this also you can think factor. This is decimal. So here you cannot think. Do not think factor here. Why? Because you are getting decimal. So here nothing is a factor. This 14 is not a factor because it is decimal. If you get integer, only then you will say factor is there. And which is the factor? Always it is denominator. So 7 is a factor. 7 is a factor of 91. 13 also is a factor. 91 also is giving you integer. 1 is an integer. So 91 also is a factor. And 1 also is a factor. Okay. So the concept is, in a division, if you get integer, the denominator can be called as factor, otherwise not. For example, okay, answer for this please. Is 1.3 a factor of 3.9? Answer for this please. Yes, no. Yes, why? Now, what they are asking is 1.3 a factor. They are asking if this is a factor, so please put it in the denominator, 1.3. Because for this, they are asking factor. And factor means something related to denominator, not numerator. So please put this in denominator and put it in numerator and calculate. Either calculate or just think. I'm easily able to calculate. This will give me 3. And 3 is an integer. And 3 is an integer. It means I will say yes. If I get integer, I will say yes. Otherwise, I will say no. Okay. So this is what is the definition of factor. And please remember this, factor is a word which is used for the number present in denominator. Do not use it for numerator. For numerator, multiple word is used. For example, if I say I'm saying denominator, 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 denominator. 7, 13, 91 and 1. These are the factors of 91. If I say opposite, I will say like this. If I say multiple, just multiple, the concept is it is used for numerator, nothing else. So 91, if you get integers, say 91 is a multiple of 7. Here also integers, so 91 is a multiple of 13. 91 is a multiple of 91. 91 is a multiple of 1 also. So I will say like this here. Ninety-one is a multiple. Please see 91 where it is present, numerator. So for 91, I'm saying 91 is multiple. I'm not saying factor. Here also I'm getting integers, but I'm not using the word factor for the numerator because that is not the logic. The logic is for numerator, multiple word will be used, and for denominators, factor word will be used. Is this language clear or not? This is the language of division. So is this clear or not? It should be very clear. Otherwise, you will not be able to understand the questions. You will not say opposite because so many students are confused in how to frame the sentence. In a division, you have to frame the sentence like this, or you can frame like this. All right. Okay. Now next. See this question also. There is some question which can be like this also. So, number of prime numbers between 30 and 50 is. So again, a direct question. Sometimes you will see in some books, they will give you a table. They will give you a table and they will say 0 to 100. How many prime numbers are there? Okay. Then 50 to 100, how many? 0 to 50, how many? 25 to 50, how many? Like this. So, I will not tell you to memorize it because again, you are not preparing for SSC and bank exams. There I can say, obviously, you require that knowledge. It will be better for you guys to remember that table so you can save some time. But here I will not say, just give 20-30 seconds to it and solve it. So tell me, how many? Quickly, do not think even numbers, please remember that. Do not waste your time thinking even number because even number cannot be prime except 2. So how many? So think odd numbers starting from 31. So 31, 33, not 35, not 37, 39, not. It looks like 41, 43, 45 is not. After that 47. So out of all these, this 39 maybe it feels as a prime number, maybe for some of you. Okay. So these are 5 prime numbers. So 5 is correct. All right. And please, I'm saying do not think even numbers. Do not think because even number cannot be prime. And any number which has the unit place of 5, think that number also. I mean, do not think that number also when you are thinking of prime because 35, 45, 55, all these numbers are for sure divisible by 5. So those numbers cannot be prime. Okay. So clear with this? Some very basic question. definition based, basically. All right, quickly to the next one. Okay, so I have given one definition and immediately below that I have taken a question. Okay, now read the definition and tell me what is the right option. I have given you the definition for your reference. Read it, understand it, tell me what is the answer. Twin means two. Pair also means two. Pair of numbers which are prime. So both the number must be prime. That is the first thing. And the difference of them must be two. That is the second requirement. First requirement is both of them must be prime numbers and the difference must be two. So Manoj Tapla, 87. Have we not seen 87 is not prime? Have we not seen it? 87 is not prime. We have already seen it. It has a factor of 3. It has a factor 29 also. It is not prime. And not prime means twin prime cannot be possible. Okay. So 87 is not prime. D option removed. 95 is for sure not prime. 99 is divisible by 3. So A option correct. Okay. So 3 options I have removed it. It's not like, sir, why you are not checking these two are prime or not? My dear, 3 options are removed. If 3 options are removed, the fourth one, I will not check it. I will assume it is right because 3 options are for sure not right. So I will assume A option is right. Okay. So clear with this? Option elimination. 3 options for sure not correct. So A option is correct. I have not checked what is right. I have removed the wrong options. So that's why I have got the right option. Okay. All right. Okay. So read this please carefully. One definition I have written. Prime factorization form. First, just tell me this. Do you already know it or do you have a little bit of idea? Answer please. Do you know this or not? Do you already know this? Not. Okay. Just answer please. Can I write 91 like this? 13 into 7? This is 91. This complete also is 91. The only thing is 91 I have written as a product. Okay, so that is also 91. 91 you can write like this also. If somebody wants 91, he can write 90 plus 1. That is also 91. So what I mean to say is, see the first one please. This representation is also one of the representation of 91. And when I observe it, it is what? Prime number. This is also prime number. So when you express a number in terms of prime numbers, that representation is called as prime factorization form. When you represent a number in prime factors form, that representation is called as prime factorization form. For example, if I say 100, 2 square into 5 square. 2 is a prime number, 5 is a prime number. You can check also. 2 square, 5 square, check please. It is 100. So I have represented 100 in terms of prime numbers. So that representation is what? this representation is prime factorization form of 100. Why prime? Because 2 and 5 are prime numbers. Now read the definition, please. Are you getting an idea now that what is the meaning of prime factorization form? Please see that. Is it clear now? Everyone. Please remember, other than the powers, everything should be prime in the representation. Other than the powers. 13 is prime, 7 is prime, 2 is a prime number, 5 is a prime number. So yes, they are correct. For example, if I say this, 100 equals to 4 into 5 square. Is this prime factorization form? Please answer. Is it or is it not? Everything other than the powers, everything should be prime number. That is the logic of the form. So, is this a prime factorization form? No. This is not. 4 is not a prime number. So, this representation is not the right representation. Okay. Now, I'm writing something. Now, do you know this that 144 is a perfect square? Do you know this? All right. Do you know 169 is a perfect square? Yes, it is a square of 13. Do you know 100 is also a perfect square? 2 square, 5 square. Right, that is also a perfect square. Now 1000. 1000, is it a perfect square? Answer please. 1000. Is it or is it not? No, okay. Now answer for 10,000. 10,000 is a perfect square or not? Just with the knowledge you have, tell me that. Okay, you are saying yes. 2000, is it a perfect square? 2000. 2000. No. Okay. So you are saying yes, 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 no, yes, and no. Where I have put tick mark, only for those you are saying yes, sir, it is a perfect square. Now, all the numbers which you have said, sir, it is a perfect square. Please see the prime factorization form and tell me, are you observing something? Please observe. The prime factorization form, please see. Are you seeing some similarity? Something. Are you seeing it? If you are seeing something in the prime factorization form, just tell me that. Are you seeing something? Correct, Chetan. Yes, prime number, obviously they will be prime numbers. That is the similarity, but that is a similarity everywhere, right? Not just these numbers. It is a prime factorization form, so only prime numbers will be there. So that similarity I'm not asking. I'm asking that are you seeing 1, 2, 3, 4? In these 4 cases, are you seeing something similar which you are not observing in these 2? Because you are saying this is not what? Perfect square. This is also not perfect square. So are you not observing something there which you are observing in these 4 cases? Even powers. So let me write this. A perfect square you are observing what? Even powers in prime factorization form. Everyone able to observe this or not? Prime factorization form. Okay. Now, if you say, sir, this is even. My dear, this is odd. See, please, 4, 2, 2, 2, 2, 4 and 4, all are even powers. Everywhere else, I have some odd powers. Okay, this is even, but this is not even. These 2 are odd, both the powers I'm saying. So this is not perfect square. So what I'm saying is, read the definition now. First is the definition of a perfect square. Then there is a note point. Please read it. So any number which is a square of some natural number, that is a perfect square. And we have seen a perfect square, if represented in prime factorization form, will have only even powers. That also we have seen. All right. Now, based on this, some questions will be there. Okay, or let me frame one question. For example, I'm asking you one question like this. Please observe this. It is not perfect square. So based on that, I'm asking you one question. $1,000 into what? And tell me the smallest. Will give you a perfect square. So 1,000 into what will give you a perfect square? Please think about it. And let me write the prime factorization form also. 1,000 equals to 2q into 5q. Think using this, please. It is not perfect square because of 2 reasons. This is not even power. This is also not even power. So think how you should multiply so that overall, I'm saying, overall, multiply with something so that overall this power becomes 4 and this power also becomes 4 because 4 is an even number. So answer please. I want to make this 3 as 4. How will it become 4? So 3 power will become 4 if you multiply with power 1. So multiply with power 1. So total it will become 4 powers. Now I want to make this also as 4. So this is right now 3. To make it 4, multiply with 5 power 1. So these are 3 powers, multiply with 1 more. So total it will become 2 power 4 and 5 power 4. Is this a perfect square or not? Please answer. If I multiply with 2 power 1, I will get 2 power 4. If I multiply with 5 power 1, I will get 5 power 4. And it is a perfect square. So what we are multiplying with? We are multiplying with 10. Okay, so 10 is the answer. Instead of saying which number to multiply, if I say divide, will the answer change? Say that please. If I say divide, will the answer change? Instead of saying, okay, we have got, okay, you should multiply with 10. If I say 100 divided by what will give you a perfect square, will the answer change? Will the answer change? You see, if you are multiplying, you will think like this. Okay, 3, how will I make it 4? Multiply by 2. This is 3. How will I make it 4? Because multiplication will increase the power, not decrease it. So 3, how will you make it as 4? Multiply with 5 power 1. Now division will decrease the powers. All right. So think like this, please. Now I'm saying not multiplication, I'm saying division. I'm saying will the answer change? All right. So instead of multiplication, I'm thinking division. So when division happens, the power will decrease. So this is 2 cube. How can I make it as 2 power 2? If I divide this by 2 power 1, it will become 2 power 2. Yes or not? Yes or not? Please answer that. Similarly, if I divide this 5 cube by 5 power 1, it will become 5 square. And both are even powers. So yes, it is a perfect square. So I have divided by 2 and 5. So can I say I have divided by 10? Okay. Is the answer changing? If I ask you how to multiply, what to multiply, what to divide, is the answer changing? Answer please. No. So answer will be same. But please remember, when you multiply, the powers increase, and when you divide, the power decrease. Okay, clear with this or not? Please say. All right. Okay. So now they will give you some number and they will ask you number of prime factors. Okay. So for example, if I say again 1000, so 1000 can be written as 2 cube into 5 cube. Next, if I say 144, it can be written as 2 power 4 into 3 square. Okay, now don't leave that perfect square now. 1000 equals to 2 cube into 5 cube. Okay. What is this form? It is a prime factorization form. Prime factorization. Why prime factorization? Because 2 is a prime number, 5 is a prime number, 2 is a factor of 1000, 5 also is a factor of 1000. Okay. Now, what I want to say is, please see that 1000 is divisible by so many numbers. I'm not asking so many numbers. I'm saying, tell me the prime factors. Which prime numbers divide 1000 completely? So tell me that, please. How many prime numbers divide 1000 completely? Tell me the prime factors, not composite factors, not any other factor, prime factors. So 2, 5, 6. How 6? So 1, 2, 5. 1 is not a prime number. 2 and 5. So there are 2 prime factors. And you can answer just from the prime factorization form. Please remember that. In prime factorization form, I have 2, I have 5. So there are 2 prime factors. For 144 also, I have 2 prime factors, 2 and 3. 5 is not there, 5 is not a factor. 7 is not there, 7 is not a factor. 11 is not there, 11 is not a factor. So whichever prime number is present, that prime number is a factor, others are not. So if the question is find the number of prime factors, first please arrange or represent the number in the prime factorization form and just count it. 1, 2, 1, 2, 2 prime factors. So one more thing. If I say 2 power 16, carefully see my question. I have 2 power 16. How many times I can divide 2 power 16 with 2? How many times? Answer please. For example, if I say 4, 4 by 2 gives you 2. Again divide this 2. Now 2 by 2 will give me 1. Now divide this by 2. 1 by 2 is not divisible. So leave it. So I can divide 4 2 times. After that, it is not divisible. It will give you a decimal. So here I'm saying, how many times can you divide? 16 times. After 16 times, when you divide, the things will come out as decimals. So 2 power 16 can be divided by 2 16 times. Similarly, if I say 3 power 9 can be divided by 3, how many times? 9 times successively. Similarly, if I say 7 power 11 can be divisible by 7, how many times? 11 times successively. Okay, so based on that, we have one question. So please solve this question. Just with this knowledge, whatever I have given you, please try this question. What is the meaning? I will not tell you. See the options, see the question. Based on the combined question, I mean options plus the question, please try to solve it. Think what they are asking and answer. Okay. So you have, I'm giving you 1 minute. Okay, take one more. All right. So please try this. Okay. Carefully see, please. First, they are asking about prime factors. Something, the question is based on prime factors. So it should be a prime factorization form. So just answer, please. Is this number, whatever expression they have given, is it prime factorization form? Please answer that. Is it prime factorization form? No, 4 is not a prime number, so it is not prime factorization form. So if you calculate directly using this, you are going to get the wrong answer. Okay, so carefully see these. First thing, I want to give you one formula. Suppose you have a power m. This is a power m. Now again there is one more power, a power m, again power n. If you have two powers like this, in that case, the powers will be multiplied. A power m into n. Or let me write like this, a power mn. So please carefully see. We have 4 power 11 into 7 power 5 into 11 power 2. So this is 4, this is not a prime number. So I have to express this 4 in terms of prime numbers. So I can represent like this. 2 square, rest all same. This is 4, this is also 4. So I'm not changing anything. I'm just writing 4 in prime numbers, that's all. Okay. Now rest all, just copy it. Copied. All right. Now, so 2 power 11, 7 power 5, 11 square. Now, please, if you are observing this, can I apply this formula there? Just answer, please. Can I apply this formula? Can I apply it there? Yes. 2 power 2. Again, one more power. There are 2 successive powers. So powers will be multiplied. So 2 power 2 into 11 will be 22. And 7 power 5 into 11 square. Okay. Now, I will ask you 2 questions. One more set of options I am giving you. Based on the options, the complete meaning of the question will change. I'm not changing the question, I'm changing the options. So, I'm saying if these are the options, tell me what is the answer. If I create new options, in that case, what is the right answer? Previously, you were saying 29 or 19. Now you will say what? Three. Can I say, when you see this, this is also a number. The number is represented in prime factorization form. 2 is a prime number, 7, 11 prime numbers. And whenever you have prime factorization form, what did I say? If you want to see how many prime factors, so just to see the prime factorization form, you will see 2, 7 and 11. So there are 3 factors. So there are 3 factors. So I will mark D option. So if I frame the options like this, D option, you will say, okay, sir, there are 3 prime factors. But how these options are created? The original options. So the original options, maybe after this, as per the original option, I'm telling you, okay, most of the student, have you not done like this? Okay, you have thought 1, 2, 3. There are 3 prime factors, but 3 is not present in the options. So now you are thinking, okay, what can I do so that I can get a number which is present in the option? So, okay, you thought, okay, 22 plus 5 plus 2, 29 and 29 is present. So C option is correct. Have you not thought like this? Okay, just add the power. There is an option present 29, so that is right. Have you not thought like this? Just having the mindset of getting a number which is present in the option. Have you not done like this? Answer, please. Have you thought this way? That how to get a number which is present in the option? that way. Yes, you have thought like this. So what is the meaning? Yes, that is right. Coincidentally, that is right. What is the meaning of this 29 is this. Carefully see, please. Okay, like I said for this, 7 power 11 is divisible by 7 how many times? You said 11 times. So like this, please tell me. Prime factor is 2. Okay, there is a prime factor 2. This expression is divisible by 2 how many times? Please answer that. How many times? How many times you can divide by 2? You will say, sir, 22 times. And 2 is a prime factor. Now 7, how many times you can divide this with 7? You will say, sir, power is 5, so I can divide 5 times. 6th time I cannot divide. 11, how many times you can divide with 11? 2 times. So total 29 times. So the meaning is this. What they are trying to ask is not how many prime factors or what different numbers which are prime numbers are factors of this. Their intention is not that way. They are saying this number is divisible by prime number how many times? So it is divisible by 2, which is a prime number 22 times. This number is divisible by 7, which is a prime number 5 times. And this number is divisible by 11, which is also a prime number 2 times. So how many times it is divisible by prime numbers? Total 29 times you can do the division. Understood with this? See, please. The intention is completely different. The options can be this also, the option can be this also. If the options are right hand side, this is the intention of the person. If the options are that way, the intention of the person is this. He is trying to ask you this. It is divisible by 2 22 times, divisible by 7 5 times, divisible by 11 2 times. All right. Anything doubtful? See, please. All right. So we will start with this again. Okay. So very easy question. 385 is clearly visible that it is divisible by 5. So 385 divided by 5, 77. Just tell me this. For example, if you want to write this, do you not know this? That to get this, just divide this number with 11, you will get this number question mark. Do you not know this? Yes or not? Please answer that. To get the question mark, 396 divided by 11, that will give you question mark. Or think like this, please. For example, if I say 385 equal to, clearly visible, 5 is a factor. Okay, clearly visible. This number is divisible by 5. So I can represent this number as 5 into something. 5 is a factor. That means this number is a multiple of 5. So this number will be 5 into something. And that something will be 385 divided by 5. Do you have this very basic knowledge or not? Just answer that. That 5 is a factor, so 385 will be 5 into something. To calculate this something, I will have to divide by 5. Do you have this knowledge? Okay. So some student who do not have this knowledge, just practice 3-4 examples and we'll continue with things tomorrow. Okay. So just one more thing. Always in the 10-15 classes, we'll end the session with this problem. Okay. So see, please find the missing number in the given matrix. So we will start the tomorrow's class with this puzzle problem. All right. So have a great day. Thank you. Attendance, please. Just a minute, please. Let me see. Just wait. Let me ask. All right, so guys, I have not got any updates regarding the attendance. Okay, I don't have any QR right now. So leave the attendance for today. Okay, we'll start the attendance from tomorrow. All right. Okay. Thank you.